I hope so. I am audible, guys. Hey guys, welcome back to Coders Arcade. This is Ashang David, and in today's video we are going to talk about session number 25. This is going to be DSA. Till now we have finished up trees concept. A lot of concepts related to tree. We have covered up BT for binary trees, BST for binary search trees. We have finished AVL trees, we have finished display trees, and to refresh the concept, one student asked us a doubt on the same series, and that was sir, you did not do the searching sorting algorithms. So today I will be doing that, and we'll take a small pause from the trees concept. Okay guys, and we will do searching algorithms. So today it will be a very small class, and I will be just explaining two algorithms here, and that is going to be linear and binary search algorithms. These are one of the basic algorithms that we should know in DSA, in data structures and algorithms, and you should know about this. So we are going to talk about this in today's live session. Okay guys. Sir, graphs when? Graphs will come, you see, after this we will have heaps, we will have priority queues, then we will have graphs. So it will take some time, around 2 weeks time it will take from now on to start with the graphs concept. Ayush. So roughly around 2 weeks. By the end of the 2 weeks more, we will be finishing that. We will starting with graphs, and graphs is going to be one of the most important concept that we will be doing. So guys, before I start with this live session, I would like to request you people to please like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon so that you won't miss any future updates. And without any further ado, one more thing I would like to ask you guys to share this live stream as much as possible, because those people who want to learn DSA all for free, and those people who cannot afford learning DSA by buying the course, they can also learn it from free. So for those people who really want this course, please share this live stream as much as possible, so that those people who really need it, they can also get it. Okay, so what is the time for upcoming lives? Generally I come at 7 o'clock in the evening, but next week I am going to come from 6 o'clock to 7 o'clock timing I will be coming. Okay guys, so 6 o'clock to 7 o'clock next week timing. This is the last day of this week. So this week I was having the timing from 7 o'clock, so from 7 to 8 I was coming, but in the next week 6 to 7 we will change the timings. Okay guys, so let us start our class, our session. Today's session is going to be a very simple session, a very small session, a very simple session, and that is going to be searching algorithms. Today we are going to talk about two types of searching algorithms. If you remember, I have left this concept in the beginning when we started this in session number 2, 3, 4, either 3 or 4. If you remember, I told that I will be doing that later in between at some particular time. So this is the time, it is enough. We were doing a lot of trees concept. So today also one comment as well came that, sir, you did not do the searching algorithms. So I will be doing that now, searching sorting algorithms. So I will start from searching, where today I will only discuss about linear and binary search. Okay guys, so let us understand about this in DSA. Okay, so DSA, we are talking about DSA, we are talking about algorithms. So first of all, understand what is an algorithm. What is exactly algorithm? Now you might say DSA, we say data structure, and algorithm. This word that we have, let us understand what exactly is this. Data structures already you have understood, like stacks, queues, linked list, trees, and etc. There are lots. Those are the ways to organize the data. But when we are talking about doing some operations are done by the algorithms. Algorithms are these programs which work on the data structure in order to perform some kind of particular operation, and that is what data structure and algorithm means. So in today's class, because we are understanding in two algorithms, we need to understand the meaning of what is algorithm first, and this is the meaning of algorithm first, guys. Algorithms are just the programs which operate onto these data structures, and this is why we call them as algorithm. Okay, so it is the way of doing some operation basically. Okay, so that is the thing. Okay, next, when we are talking about algorithm can be divided into many different ways. We have searching, we have sorting, and etc. In etc you can say we have traversal algorithms, we have tree algorithms, you have graph algorithms. Some good example of these are Kruskal's, Prim's, minimum spanning tree, and Dijkstra's, and etc. again. These are all algorithms. Ultimately algorithms are the programs which actually does perform some particular type of operation onto a data structure, and in this case we are talking about any data structure. We say a data structure can be an array, it can be a stack. For example, a basic example is that a stack is a data structure. We already know that a stack is a data structure. Push is the algorithm, I can say, which performs the operation of entering the elements into the array, into the stack. We can say pop is also an algorithm. Okay, guys, like that. So like this, in graphs if you go, then you will come across Prim's and the popular ones, Prim's, minimum spanning tree, MST. For MST we have Prim's. For MST only we have Prim's, but yeah, then we have Dijkstra's for finding minimum path. This is for finding minimum path finding. So these are all the algorithms. Understand my point? And the very basic algorithms that we usually learn from the beginning, from the starting, is gonna be your basic algorithms, which is called as searching and sorting algorithms. So ultimately these things are doing what? These things are basically searching something, or maybe sorting something. Something, in the case we are talking about collections, any type of collections. It can be an array, it can be anything, basically anything that you want to perform. A good example is, usually we do it in arrays. You can do it in linked list, you can do it in trees, etc. All the data structures wherever you can perform searching or sorting is your searching sorting algorithms. In today's class we are going to talk about arrays, because as I told you we are starting with this, so I told you that I'll tell you in between of this, so I'll tell you about that. So right now let us start with in today's class we are going to discuss these two. First, linear search. Second, binary search. Linear search and binary search. Speaking of linear and binary, what do you understand by the term linear, or what do you understand by the term binary? Linear means in a straight line, in a straight order, in a simple straight line. Binary means 2. So what can you or how can you relate with this simple line, linear or binary 2? In terms of searching, when we try to search in a linear way, for example, you have an array given, some array, random array, okay, and you have some elements, let's say 50, 60, kind of like that, okay, and yeah, linear is a line, yes. So for example, here you want to search for 30. So what do? You will search it in a straight line. How? You will start from 1, then you will go here 20, then you will go 30, and this is the place where you will find 30. So you found 30 in O of n times in this case. Are you getting my point, guys, what I am trying to say? This is like the linear search. So you start from the 0th index, and one by one you keep on traversing into every index, comparing it. So it is like, imagine this example. Say suppose you want to search for a file and you have to go, so you have to, let's say you want to search for a, let us say you want to search for this bottle, okay, you want to search for this bottle, this water bottle you want to search, okay. Now if I want to search this water bottle, and if I give you a room full of water bottles, there are hundreds and thousands of water bottles, okay, there are hundreds and thousands of water bottles. Now you go there and you first see this, and then you keep it, this is not things, then you say another thing, another bottle, then you check it, it is not there, and like this you are checking each and every bottle. This is what you call as linear search. I hope so that this is very much clear. Linear search is the way of searching the data in a straight line, or you can say checking basically every possible condition until you meet the result, you met the result. This is what you call as linear search. Searching in a linear style, looking for that particular result by jumping onto every single node. This is what you call as linear search. So in this case, if I want to do any type of search, this linear search in this case, I can just straightforward write one single for loop to iterate over this and write if that ARR of I is equals to the value which you are looking for, then you've got the answer. Yeah, checking one by one and eventually finding the one, and this is what you call as right. Absolutely correct. Your username is Pikachu. Alright. I hope so you've got my point. Right? Very easy concept, guys, very easy. Now, oh, really, sir, what is O of n meaning? Okay. Guys, really, O of n. I have written, you have an array, for example, okay. You have some random number of data, 0, 1, 2, 3, 4, 5, 6, 7, 8. So you have in total 9 data, starting from 0 going towards 8. Okay, really. Now let us say you have 1, 2, 3, let's say 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. You asked me what is O of n. This, what I am talking about is time complexity. Time complexity. Time complexity. Okay. What is time complexity? This is called as big O. Big O notation. Big O notation. Big O notation, which is used to express the time complexity. Here n means Here n means that we found the element nth time. For example, you are looking for this 50. So first you went right here, 1, then 2, then 3, then 4, then 5th time. So this is your nth time. This is your nth time. Okay, really, I hope so that this is very much clear to you. This is the nth time. Okay, time complexity is measured in this way. Now speaking of time complexity, if I tell you a little bit of time complexity can be measured in two ways. Usually there are two notations which are usually used in most of the time. We use omega and big O. Nowadays we don't use omega, but we use big O. And then we have to write in the suffix some number. This number represents the time taken by your program, or I can say algorithm to do some task, and this is what you call as time complexity. Okay, my camera went off. Understood this, guys? So this here, if I write here n, let's say if I have written here n, this n means nth time. So we don't know the time is dependent upon the for loop here. How many times? Yes, understood, yes. How many times the for loop is running? It depends upon that time. So we don't know at what time we are going to get that. Now you may find that 50. It is highly likely possible that you may found this 50 at this place or this place or this place, or before or after, anywhere. Are you getting my point? So in this case, when you really don't know at what time or how much time it is gonna take, in order to reach that or find that particular element, we write O of n. We don't know, n is some time, nth time. Okay guys, understood this? This is time complexity, guys. Okay. Yes, I will explain the space complexity also. I think we should guess. I think in worst case O of 8 is the time complexity. Am I right? Yes, correct. Ravi, absolutely correct. Okay. Let me explain what Ravi said. So as I told you here that there are not 8 exactly Ravi, but 9, because here we are starting from 0, so it will be 9. Understood? So in this case, you see, acha, let us talk about this properly. If I tell you a little bit of time, there are two things, guys. Time and space. Time and space complexity. Let us understand a little bit about this first. Then you will understand more about the concept, guys. Okay. So first, I told you what exactly I told you. I told you about the time complexity here. Time complexity means, here the time means time taken by your algorithm to do some task. Okay, time taken by your algorithm to do some task. Listen to this. Time taken here is the important. Okay. Now, what is this space? Space means how much auxiliary, or auxiliary means extra space is being taken by your algorithm. I hope so that this is very, very much clear to all of you. Understood this? So there are two things, guys: time complexity and space complexity. Time complexity is the time taken by your algorithm to do some task, or space complexity on the other hand is the how much auxiliary space. The auxiliary the auxiliary space here, guys, will be telling us how much extra space your algorithm took. It can be an whole array, or it can be a whole variable extra in this case. In some program, when you use too much of a space means too many arrays to solve the problem. Say suppose you wanted to do the problem, or you wanted to solve the problem in the same array, but you had taken a extra array. In that case, the space complexity will increase. I hope so. This is very, very much clear. Now, in both the cases, we have three cases. First, we have best, then we have average, and then we have worst case. Best case, average case, worst case. Best case is always big O of 1. Understand this, guys. Big O of 1. As I told you, big O notation is used, and 1 means this is imaginary case or the best case. Best case will always be O of 1. Imaginary case will be always O of 1. O of 1 means in the first attempt only you got the answer. In the first attempt only you got it, you searched it, or whatever task you are doing, you did it in the first attempt only. That means you cannot be more efficient than that. I hope so that this is very much clear to all of you, whoever is listening to this class, right? If you got it, say suppose I told you to search this water bottle in some room, and as soon as you entered the room, you found it. This is your first attempt, you found it, an O of 1. In terms of programming, we do not calculate this case. We do not calculate the best case, we do not calculate the average case, we always calculate the worst case. Worst case, whatever the worst case comes, that is going to be the most efficiency of your program. The most efficiency we are going to check in the worst case. In the worst to worst scenario, if your program is able to do O of 1 or nearly to O of 1, if imagine O of 1 is going to go there, that means your program is the most efficient program you have written. Understand the point? If I say here O of 1, O of n means it took n number of times. This is much more slower, because we don't know what will be the value of n. This n value can be maybe 10,000 also, or some infinite value also. We don't know. So this is kind of like the worst, the baddest case. We don't want this. This is one of the baddest or worst case. If your program's worst case is coming up to O of 1, if your worst case is coming up to O of 1, that means that is absolutely efficient. But in most of the cases, your worst case comes in O of n. Now, this depends upon different algorithms and the style of code you write. For example, I took an example of linear search, right? Here, we have taken example of linear search, right? Now, you see that you started from the beginning. This was your first attempt. Then this was your second attempt. This was your third attempt. This was your fourth attempt, and fifth attempt you got it. Now, this could be possible that you may find it at 10th attempt or 9th attempt itself. or it might be possible that you might get it in first attempt itself. Here we are not sure. So we write O of n, which is one of the worst cases. It depends upon where the value is actually placed in reality, and that is how it is gonna be used and created. I hope so that this is very, very much clear to all of you, right? Now, speaking of space complexity, even space complexity is also measured in best case, average case and worst case. Space complexity is also denoted as same. If O of n is your space complexity, if big O of n is your space complexity, then we say that your program is taking n number of space. Okay. If a program is O of 1, that means your program is taking very less space, or basically no space. I hope so that this is very, very much clear. So same notation you will write, same exact notation you will write for both time and space, and it will do the job for you. I hope so that this is clear to everyone in the chat. I hope so. Riley, then Pikachu, then D Ayush, then Ravi. Correct? So all of these are the time complexity. Okay. All right. My camera went off. Let me just switch it on again. Apologies for that, guys. I am the only one managing the camera here, so I need to only do the whole thing. So I'll be like this in between. Okay. I hope so that this is very much clear to you. Now, let us continue to where we left. Okay. So guys, this was your linear search. In a linear search, how do we represent the average case? Oh, average case. Average case is also represented by the same big O of n. Same big O notation. You see, big O notation is only used. I hope so that this is very much clear. Okay, guys. Big O notation is only used. The same thing, but we don't calculate average case. Pikachu, we don't calculate. Only calculate. Remember, only calculate worst case. In any type of algorithm, we only calculate worst case. Got it? Representing part is done like the normal and how you do it. O of, big O of n notation, big O of. Okay? Now, one thing I would like to tell you about this, very important thing, that there are three things, multiple things. O of 1 means this is the best. O of n means this is the worst. Then we have O of log n. Log n means exponentially n has come down to very less. Very less. You got my point? Very less. That means you can say half of n. You can say half of n. Half of n. This is better than n. I hope so that this is very much clear to all of you. Okay, guys. Okay. So I will actually write it properly somewhere here. Okay. You have O of n, O of 1, best, O of n, worst, O of log n means better than O of n. Then you have O of n square. Guys, this is the worst. This is the worst. Okay. If this is worst, then this is okay. This is okay, better, or okay, or fine. Okay. But this is worst. This is worst. Okay guys, this is worst, while this is okay. This is okay. Okay. This is the best. This is the best. Wow. This is the best. Okay. This is, yeah, better than. I hope so that this is very much clear to all of you. Okay. Majorly you will see this. And guys, I wanted to explain you this, that you see, when we are talking about a square, how does this square happens? When you have for loop inside for loop. Let us say this for loop is running for 10 times. This for loop is also running for 10 times. Understand a point? So for every iteration of this, it will run for 10 times. Like this, we know this guys. And when this happens, it goes O of n square. Square means, because for every iteration, this is gonna run for 10 times, means this is gonna be 10 to the power 2. Here n is 10 and power is 2. So 10 to the power 2 means 100 times this for loop will be running. And you imagine 100 times if you run anything, you see how much time it will take. Clear? I will take another whole class onto this, specifically talking about time and space complexity. Okay, don't worry guys, keep attending my class, and in one class I will explain you all about time and space complexity in a proper way, because it is something which I need to show you the code for again, and then I need to explain you how it is done. Okay guys, but I hope so for your understanding this is clear for today's class. Okay, imagine if this was for inside for, there was one more for which is running for 10 times. This for loop is inside this for loop, this for loop is inside this for loop, nested to nested for loops. So totally like 10 into 10, n into n. Yes, 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 Pikachu. Okay. Now what happens if it is for inside for, 3 times nesting we have done? Then it will become O of n cube, even worst. Even worst. I hope so that this is very much clear to all of you, right? So basically, never try to go into exponent powers in terms of time or space complexity, which is going to be very bad. If your time complexity is coming in exponential, then you will 110% your program will not run at time, and it will not be accepted in the code or in any exam. Understood my point? So make sure that whenever you write algorithm, you write like that, so that it runs in O of either O of n or O of, right? Yes, Pikachu. N to the power 3. Correct. Yes. But anyways, let us continue here where we left. We are talking about this. This is your linear search. O of n is going to be the time complexity. Alright guys, let us see the code quickly. So the idea is simple. You start iterating over the array, and if the ARR of I is equals to the key, that means if the ARR of I which you are iterating on is itself is the value or is the key, in that case then you will return that particular index. This is your linear search. Easy. Here we are going till size. So O of n, time complexity will come. Very simple guys. I hope so that this is very much clear to all of you. I will give the code into the comment section, and I will pin this code in the comment section, so don't worry about it. I hope so that this is very much clear. This is your linear search. linear search in a linear way we are doing it. Going and searching, starting from 0 index till the size of the array, and then if the ARR of I is equals to 0, then that if that particular value is found, then you return it. If not, then you enjoy. And you hope so. I hope so that this is very much clear to all of you. Apart from this, next, what exactly is the next type of sorting which we are here for, and the at is gonna be binary search. Binary search, binary search, binary search, binary search, binary search. We are talking about binary search. Binary search. Guys, recently I have taught BST, binary search tree. There we have written the whole code. You have already got it. For someone who have not seen the session of BST, understand it here. Say for example, you have a array. Okay, you have 1, 2, 3, 4, 5, 6, 7, and let's say 8. There are 8 elements. There are 8 elements. Okay, what we will do? We will find the search. We will divide this array into half. We will divide this array into half. We will divide this array into half. Binary means, and my camera went off. So let me switch on my camera again. Guys, binary means 2. So I'll cut it in 2 parts. I will continue. Chat got disconnected. I hope so that it is working, it is connected, yeah. Okay, we are back in the live. Okay guys, so we are going to cut this whole array into half, and we will divide this. We will find the midpoint. Imagine midpoint is 4. This is our midpoint. Midpoint, guys. Okay, this is your midpoint. Now when we are talking about the midpoint, why we have taken up the midpoint? Check. If you want to find 8, you will check if 8 is greater than 4 or if 8 is smaller than 4. Which one is true? 8 is greater than 4. If the point is greater than the midpoint, then you will go on to the right hand side. Of course, you know. This means, what if there is an odd element? How do we divide? Yeah, for that we have a formula to find the mid. I will tell you. Okay, don't worry. It can be a little bit on the left or it can be a little bit on the right. No worries. Not a problem at all. Okay. To find the mid, I will tell you the formula as well. But you will find the mid and then you will compare that with this mid, and you will go either on the left or right. So the idea is simple, guys. Here, first of all, you need a sorted array or any sorted collection in the sense. Hope so that this is very much clear. Yes, we will take it as 6. Yeah, Pikachu, it's kind of like that. Yes. So that's how you do it. Okay, I hope so my stream is visible, right? Because in my chat it is not showing me any stats actually. But anyways, okay, if you can see, then that means if you can chat, that means you can see me. Anyways, let's continue. Okay, so that means you need a sorted array. First of all, and as soon as you got the sorted array, you will just check that index with the midpoint. If the index is, or if the element which you want to search is greater, you will go on the right hand side, and if it is lesser, then you will go on the left hand side. So guys, how come this binary search is better than linear search? You see, we did not even check for half of the thing. Yes. Yeah. Yes. So guys, you see, we did not even check half of the things here. If the array is of 8 length, we did not travel the 8 lengths. We only traveled 4 lengths. I hope so that this is very much clear what I am trying to say. Correct? But in this case, you will just go onto the right hand side, and what you will do, you will search for that element. So this way your time complexity for this algorithm comes up to O of log n. This is where your time complexity will come as O of log n. Yes, Prerna it seems, right? Prerna, yes, Prerna, correct. Less time complexity, yes, you are correct. Log n we will get this time. O of log n will be the time complexity. I hope so that this is very much clear to all of you. Correct? This is why binary search is better than linear search. Okay? So I will be showing you the code now. So I must be having the code right here. Right. So this is the binary search. You see, I have passed the array, I have taken up the n is the size of the array, and key is the value that needs to be searched. So we have defined the starting index as 0 and ending index as n, okay, and we have said while start is lesser than or equals to end, we are going to iterate, but we are going to iterate where? We will find out the midpoint. How do we find out the midpoint? Start plus end by 2. This is the formula. We will say start plus end by 2. Okay. So 0th index plus the last index divided by 2. Whatever index comes here will be your midpoint, and that midpoint will be used to check. What if the midpoint itself is the value that you need to search? In that case, you will return that mid, then the time complexity will become O of 1. Understood my point? Then you don't even have to do anything. Yes. If the array is greater than, if the ARR of mid is greater than the key, then you have to go to the left. Okay. Otherwise, you will go to the right. So you can define end is equals to mid minus 1. And start is equals to mid plus 1. Redefine it and do it in the loop again and again. So you have updated the end points and the started point, and then the while loop again is started until it finds out again the midpoint, and keep on doing until this condition is hit. Yes. If the mid case, if the error of mid itself is the key, then it will be of 1. I hope so that this is very much clear. But in this case, if the value is not at the midpoint, then the time complexity will come as O of log n, which is just half the n, as I have just now explained to you guys. Clear? Pikachu, Prerna, Riley. This is linear and binary search, guys. I will give the link of both the codes. I will give the whole codes copy pasted in the comment section below. I will pin those up so that you can find it easily, and the notes will be given as soon as the session will be ending. I will put up the notes links everywhere, and I will be sharing with you. Follow us on in Telegram, guys. In Telegram, very soon we are going to start with the mock interview sessions. So if you are interested in getting mock interviewed, then if you want to appear into our mock interviews, then join our Telegram channel. Telegram channel's link is already given in the description below. Guys, Pikachu, Prerna, please join our Telegram channel also. There you will find updates related to all our things related to DSA I will be doing. For more updates, follow the Telegram channel only. And other than that, we are also, if you think that this course is going very long, because it will take the whole month to finish this. So if you are thinking that this is very long, then I have the offline and online courses also that you can join in our company. That will be paid, but yeah, more detailed than this, and I'll be only teaching you DSA. I hope so that this is very much clear. For more updates related to placements or even internships, we are still working so hard to get internships and placements, guys. We are trying to get our company getting connected with other MNC companies also for placements. So stay tuned and stay connected in our Telegram channel for more placement opportunities, such that you are able to also get it. Alright, guys, that's all for today's live session, guys. If you have any doubts, please ask me. We can start the live doubt session, and other than this, if you have any doubts, please do ask me. I hope so that you have understood the time complexity really well. If not, then I'll be doing another class over that in depth for you to understand, to join that class. For today's class, the time complexity which I have explained was enough. But if you want to understand time complexity, I will again take a separate session for that. So stay tuned for that, guys. I hope so that this is very, very much clear. Okay, and my camera also went off. And my camera also went off. Yeah, it came back. I hope so that this is very much clear, guys. 71 views, 6 concurrent views. No doubts. Very good. Very good. So, guys, yes, please, in depth, very helpful. Yes. Stay tuned for that. The next live session I will be conducting will be on Monday. Yes. The next live session which I will be conducting will be on Monday. I will be teaching their trees concept again. KD tree and red and black tree are left. There are two trees, KD tree and red and black tree. K dimension tree and red and black tree. Red and black tree is the again self-balancing tree, like how we have done AVL in the previous session. KD tree is the kth dimension tree which can have up to k dimensions. So that is the case, guys. I hope so that this is very much clear. On Monday we will be coming back live, and there I will explain you all the other concepts. So guys, that's all for today's class, guys. I hope so that this is very much clear. If you don't have any doubts, I'll be switching off the live session, and I will see you again on Monday, guys. Well, if you have any other doubts, please do let me know here. I am here for another 2-3 minutes. Prerna, Riley, Pikachu, all of you, please follow our Telegram channel also. We have a Telegram channel as well. So this is our Telegram channel, guys. I hope so that you are getting my point. See here, this is our Telegram channel. Okay. It's called as again Kodazake. Okay. This is our Telegram channel. Follow this up, guys, for more such content and updates related to placements, and update related to placements, update related to internships, updates related to DSA, updates related to everything. I'll be posting that there. Need the derivation of binary search. Binary search complexity is log n. Derivation. How would you do derivation? Derivation. You can directly say this. For mathematical derivation, I will pin that in the comment section. I need to check that. What will be the roadmap for learning DSA to get placed? Yes, Prerna. Yes, roadmap in session 1. Yes, correct, Riley. Oh, Riley, you are watching all our session from the beginning. Very nice. Hope so. All of this is clear. Correct, guys. Any other thing? We'll be switching off the stream now. I will again see you. I will pin up all the information related to this, and I will oh, that's really nice. Well, I'll give all the resources into the comment section below, guys, so go ahead and check for that. And that's all, guys, for today's live session. I hope so that you have understood this really well. Next live session I'll be doing it on Monday. Monday, the timings I can take it on either 6 o'clock. 6 o'clock is fine. 6 o'clock in the evening is going to be fine. I'll be scheduling the live session for 6 o'clock in the evening. I'll see you guys again 6 o'clock in the evening, guys. So, yep. Thanks for watching, and I'll be switching off this live stream. The derivation part, as you are saying, I'll pin up the concept in the comment section below. I need to check that once, and once I check that, then I'll tell you that in the next session. I can do that. Rishabh Reddy. Really, yes, I watch every day trying to catch up to trees concept. Oh, very nice, Riley. Prerna. Bye, sir. Bye bye. I hope so that today's concept is very clear to all of you. Thank you. Goodbye. Goodbye. Bye bye. Bye, guys. 11 people are sitting right here in the chat. Alright, guys, I'll be switching off. About that, Rishabh, I'll be pinning up the derivation in the comment below, and I'll explain that in the next class. Okay, guys? Alright, then I'll see you in the next session. Till then, take care, and don't forget to like, share and subscribe. Okay, guys? I'll be finishing up this. Okay, guys. Bye bye, bye bye. Thank you, Prerna. Thank you, Riley. Thank you, Pikachu. Thank you, Rishabh, Prerna. Thank you, guys, for attending today's class. Ravi, D. Ayush. Bye bye. Take care, guys. I'll see you tomorrow. I'll see you day after tomorrow on Monday.